uniform motion problems. This means there's no like accelerating, decelerating going on. So it's just something that's like moving at a steady speed over an entire distance. And looking ahead, here's one vehicle versus two vehicles. And pretty simply you can guess that one vehicle is easier. On Alberto's drive to his aunt's house, the traffic was light and he drove the 45-mile trip in 1 hour. However, the return trip took him 2 hours. So here he is going 45 miles and going 45 miles back, taking him 1 hour and then 2 hours respectively. And looking at this, I'm sure you can find a quicker way to figure this out than the way we're about to do it. But the way we're about to do it is really because they want to kind of hammer home the idea of the weighting of the different times. So the first trip was 45 miles for 1 hour. Now the second trip took him 2 hours, but it was the same trip, so it's half of that. So he did 22.5 miles per hour for that whole 2-hour trip. So if I'm looking at like a weighted average problem, then it's not like I'm going to just do 45 plus 22.5 and take half of that or something. It's not going to work that way. So in my numerator, I'm going to say, well, 45 miles per hour is how he drove for 1 entire hour. Then on the return trip, he drove 22.5 miles an hour for 2 hours. And because this entire trip was 1 plus 2 more hours, we're going to find the average of those over 3. Multiplying those out and then adding them together, you're going to get 90 over 3, which is just 30 miles per hour, which is his average trip. And if you're like, well, that was a silly way of accomplishing that problem, I'd agree with you, because you're probably just like, well, round trip, what did he do? Well, he traveled 90 miles, 1 hour in one way, 2 hours back, and the average of that's just 90 over 3 is 3 miles per hour. Yeah, I'm going to agree with you there. So I think it's a foolish way to do these problems, but whatever. It's the way they choose to do them. Exercise. Austin jogged 2.5 miles in 16 minutes and then walked 1 mile in 10 minutes. So let's just do this the way that makes most sense to us. And let's say, well, his total trip was 3.5 miles. And then you might be like, well, I'm going to just do divided by 26. And when I do this problem, I get a decimal of 0.135 miles per minute. And since that's kind of a weird setup of units, let's go ahead and do this with an extra step involved. So here's 3.5 miles per 26 minutes. Well, I'd rather think about this as miles per hour. And if I were to write this the wrong way, first of all, I could be like, well, there's 1 hour in 60 minutes. And when I want my minutes to cancel out, well, I look up top and I have miles and minutes. Well, those don't cancel out. And I have minutes, both in the denominator. So this would actually end up with miles in the numerator, hours in the numerator, and then minutes squared in the denominator. And so that means that I would not have used a conversion factor, converting my minutes to hours. So instead it would have been much better if I would have written that there are 60 minutes per 1 hour. Now maybe that wasn't even something that you would help you to think about, but whatever. Problems get more challenging. It's nice to look at stuff like that. And when I figure this out, I'm going to get 3.5 times 60 divided by 26 equals approximately 8.1 miles per hour. And that would be his average speed. Now hold on, wait, why did I not just take this number and just multiply it by 60? Well, I could have done that, but here's the tip. If you do that, then I want you to use the answer key in your calculator so that it will recall this number, because if you use a rounded number to multiply by 60, that means that your answer is going to be further off than if you did not round earlier on. So that's why you should always avoid rounding until the very end of a problem. That's an important concept in science. Okay, 6 minutes. I'm having a tough call here. Keep filming, keep recording this, or start a new one. We're starting a new one.